Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARK Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARK. All statements made regarding companies or securities are strictly beliefs and points of view held by ARK or podcast guests and are not endorsements or recommendations by ARK to buy, sell, or hold any security. Clients of ARK Investment Management may maintain positions in the securities discussed in this podcast.
All right, I'm Will Summerall. I cover AI and software at ARK Invest, and I'm joined today by Alex Wang at Scale AI. So just to start off, Alex, do you want to just briefly explain what Scale AI does?
Yeah, first of all, thanks so much for having me on the podcast. Really excited to be on here. I listened to a podcast about gene editing, which was very, very interesting, and I learned a lot. So at Scale, we build AI infrastructure and products for every organization in the world to be able to utilize AI technology. So we do this for everywhere from large automotive companies, people building self-driving cars, all the way to the government. So we work very closely with the US government, the US Department of Defense, to large insurance companies, to large e-commerce companies. So nearly every company we think should have the capabilities of artificial intelligence in their toolkit, and we want to be the ones to provide that.
Makes sense. And maybe you could back up a little bit and just talk about the origin story and why you started Scale. What was the initial problem you were trying to solve?
Yeah, so I was studying AI and machine learning at MIT before Scale, and I was actually really inspired by the technology because it was this clearly very powerful technology that sort of had this potential that, from a science fiction perspective, I guess, was very appealing and alluring. So I wanted to build a side project. I wanted to build a camera inside my refrigerator that would tell me when my roommates were stealing my food. And I worked on that application for all of a few weeks before sort of hitting this major roadblock around getting enough data to be able to build this algorithm to be able to detect when my roommates were stealing my food. And I kind of realized that this wasn't going to be a problem that just I face, but it was going to be a problem that nearly anyone who wanted to build a product using artificial intelligence was going to face around building data sets, getting the right data, and continuing to improve those data sets to build incredible AI. So built Scale to solve that problem, and really with the view that if you solve the sort of data problems and the data foundations of AI, that's going to actually enable almost everyone in the world to be able to build great AI and sort of transform their businesses.
And when you started, I presume that a lot of the sort of labeling services that you were doing were manual. You had humans sort of curating data sets. How has that evolved over time? Is it still predominantly done by humans, or are you starting to introduce more technology into the loop?
Yeah, definitely. So to your point, if you look, in the early days of AI, a lot of this sort of data work was done entirely manually. So ImageNet, which was this data set produced by Professor Fei-Fei Li, who is a professor at Stanford, she worked with her lab to produce this data set ImageNet back, I think, in 2007 or 2008. And that really, most people would say that was sort of the beginning of the modern age of AI or the modern age of deep learning, because it was sort of the first large-scale image data set that was labeled and ever existed. One of the things that she'll say is between creating ImageNet and a decade after ImageNet, so let's call it like 2017, 2018, the act of getting data sets was still just as awful. Nothing had changed. All these other things that changed around her, our computer chips have gotten way faster, the code gotten way better, all the algorithms have gotten way better, but the process of preparing data sets and data for machine learning was just as awful. So our goal at Scale was to really totally bend the curve of that. And how do we, one of the things that we talk about is the Moore's law for data. How do we enable a Moore's law-like curve for data for machine learning, where every year or every 2 years, it's 2x more efficient or meaningfully more efficient, exponentially more efficient to get data for machine learning applications. And we've been able to actually play that out and live that. So, Scale started in 2016, and, every year, every 2 years since the start of Scale, we've been able to meaningfully improve the efficiency of the algorithms by automating more of the process, building better tools, creating better systems to identify what really needs human attention versus what doesn't. And so we've driven basically these sort of like exponential gains in the efficiency of the overall system of producing data for machine learning algorithms through great technology.
Makes sense. And it's kind of a crazy concept to have a research scientist, PhD, who's probably making $1 million a year at a big tech company, spends a disproportionate amount of their time trying to curate data. So it seems like a low hanging fruit. I'm just curious, like, practically, how do you introduce more automation or more technology into that process? How do you go from a sort of a system where you literally have humans looking at an image saying that's a banana to a system where a lot of that is done by software and you only point human in when necessary?
It's moving towards a paradigm that I think is, generally speaking, a paradigm for the future, which is instead of humans kind of being the author and editor, you sort of have automated systems, AI in general, that is sort of the author and humans are the editor. And that's sort of the general paradigm that you shift into, where, the first pass or as much of the work as possible is done automatically, but you also flag, where are the spots where the algorithm may have made mistakes, and then you have humans sort of look at those, flag those, and sort of resolve those kinds of issues. And I think this general paradigm of AI authors, human editors, is one that we're going to see all over the place. I think with GPT-3 like systems, you're starting to see that in writing or in copywriting or all these kinds of applications where people will use AI to inspire them and create a huge amount of content that they then go in and sort of like make sure it fits a proper narrative or is to their style. I think we're going to see it in imagery with all these like image generation systems like DALL-E. Humans are going to initially create an image, and then we're probably going to edit the output of DALL-E to sort of like suit whatever application we need. It's pretty clear that this is going to be how humanity interacts with AI overall in the coming decades, as a sort of editors and taste makers on top of content that AI produces.
Looking forward, if we say 5-7 years in the future, AI system GPT-3, whatever the GPT-3 is, and 5 GPT-7 or 8 or whatever it ends up being, is sort of at or beyond human levels of performance across a variety of tasks and domains. Do you think AI will start to automate human work and displace humans? Or do you think that the best AI systems will have a human in the loop?
I believe very strongly in the human in the loop sort of path, or the human in the loop route. Another way to put this, there's this great article by this professor at another different professor at Stanford. This was by an economist named Eric Bernolfson, called The Turing Trap. So I think that because of the way that Turing initially constructed the Turing test, which is I think he originally called it the imitation game, actually, where you're sort of trying to produce these AI systems that imitated humans. It sort of almost implicitly created this sort of belief that we're going to have AIs that replace humans, rather than what I think is more likely to be the case, more technologically feasible, as well as sort of more productive and sort of better for humanity, which is augmentive AI. So how do you have humans use AI as a tool or work together with AI to basically produce even better and greater things? Another way to think about this is, I think AI is market enabling rather than sort of just a cost takeout. That's sort of maybe the more business framing of this, where I think using the capabilities that we have with these modern AI systems, we're going to be able to do things that were fundamentally impossible beforehand. And those new capabilities that businesses are going to have, or we as people are going to have, are going to sort of usher in entirely new planes of creativity, entirely new planes of content, entirely new planes of sort of expression that we wouldn't have seen before. I'll give one good example here. This is sort of one that I've been thinking about a lot, just on the side. One of the really cool things that you can kind of squint and see with systems like DALL-E 2 is that the production costs of producing really compelling video or really compelling sort of TV shows or movies or video content are going to go down. A lot of what makes those processes so expensive, which is visual effects, special effects, very good video editing, all those things are going to become significantly more efficient. And instead of it costing hundreds of millions of dollars to make a Marvel quality movie, maybe that'll cost tens of millions of dollars or even single digit millions of dollars over time. And I think what that's going to enable is just like this wealth of incredible content that comes out. And we're even going to get content that is more tailor-made to you or more tailor-made to your interests over time. So we're going to see this sort of like explosion of content. And there's probably going to be different forms of content that like are economically infeasible to generate today that people are going to explore, like, kind of like I mentioned, like purely personalized content or stuff more like that one Black Mirror episode where there's sort of like choose your own adventure. There's a lot of, I think, interesting forms of expression that are going to happen that, again, are just economically infeasible today. Generally speaking, I believe a lot in sort of the market enabling potential of AI rather than as a replacement to humans, because I think, the history is pretty clear. Whenever humans are given some crazy tool that allows them to do things in new creative ways, we figure out, really innovative models and business models.
Yeah, for the entire history of technological innovation, people have been saying the next technology is going to lead to mass unemployment, and it's actually been the opposite, right? It's led to more prosperity. And to your point with content generation, we did a survey and took an image from DALL-E 2 that we think is kind of representative of the type of images it creates, and found that it would cost about $150 to have a graphic designer produce that image. And the commercial pricing on a single image from DALL-E 2 is about 3 cents. And so you have something that would normally cost $150 that's now produced for 3 cents. And maybe you need DALL-E 2 to generate multiple images, multiple iterations before you find the one you want. But 5,000 iterations for the cost of one that's human generated. And so, yeah, that could certainly lead to an explosion of productivity. The other thing that we've seen historically, and I'm curious if you guys have seen this anecdote as well, costs to train large models like large neural nets fell at about 65% a year between 2015 and 2020. We think it's going to continue to fall at around 60%, a combination of algorithmic improvements and underlying hardware capability. That's incredible. I mean, if you look at some of the drivers of technological adoption and inflection points for each market's cost declines is really one of the underlying themes. And a 60% cost decline is unprecedented. That basically means that, say, GPT-3, which costs, the final training run was like $5 million in 2020. If you start playing that out through 2025, it's going to cost a few hundred or a few $1,000s. And so it's just an insane level of cost decline, which unlocks all this capability. And dollar for dollar, if you assume that sort of performance scales linearly with compute input, a dollar of input equals 1 unit of performance today. That's 2.5 the next year, and that continues to compound at 2.5 every year. And so it'll be this sort of explosion of capability. I'm curious if you guys are seeing similar cost declines in any of the work that you're doing with sort of neural nets or large models.
Yeah, for sure. It's actually, to your point, it's totally incredible. I think because we're fundamentally so early in the sort of study of artificial intelligence and sort of the study of deep learning that we're able to see just dramatic improvements that are, again, as you mentioned, unprecedented in any other field. My parents are both physicists. There are not 65% year-over-year gains in the realm of physics today. It's absolutely amazing. And I think that in our context, what we see where we're applying artificial intelligence to a lot of practical problems within businesses and other organizations, whether it's applying it to satellite imagery to drive greater understanding of the world or applying it to understanding website behavior. So for e-commerce companies who will sell more products more efficiently, or whether it's sort of working with autonomous vehicle companies and being able to process the sort of massive amounts of data that they receive. In each of these cases, you're actually, right now, we're in a state where we are inundated with data. We have like far more data coming in than organizations have the ability to efficiently process. And the algorithms that we've built up and that our customers use have enabled just orders of magnitude scaling in terms of the amount of satellite imagery that can be processed, or the amount of vehicle data that can be processed to build self-driving cars, or the amount of sort of like web data and e-commerce data that can be processed efficiently. And these order of magnitude gains enable us to build, just be far more aware, be more intelligent, and build better systems that are fundamentally more efficient. And this is kind of what I mean by doing things that, I think a lot of times people get really stuck in thinking about what are the things that we can do today, how efficiently can those be done with AI? Which again, I can't stress enough is the wrong question. The right question is, what are the things that we couldn't have done yesterday that we can now do because we have artificial intelligence or we have great algorithms or whatnot? And that I think is, I mean, humans are going to figure that out regardless. That's sort of that's the constant direction of innovation. And that gets you oriented towards thinking about what are the actual ways in which the world will change rather than thinking like, oh, AI is going to replace all these human jobs. That's not going to be true, but it's going to sort of create these massive new industries that you couldn't have really imagined before. I'll give one small example because I think it's a very small example of this, but it's very interesting. If you look at TikTok as a platform, one of the beauties of TikTok as a platform is how interest-based the recommendations are. When I'm scrolling TikTok or when anyone's scrolling TikTok, the content that they see, they don't know any of the people who are producing that content. A lot of the people who are producing content on TikTok who go big, they're very random people all around the world. So you don't know them, you don't have any connection to them, but they're producing content that's very relevant for you, and it makes it this incredible experience. That was powered through breakthroughs in artificial intelligence and machine learning, because all of a sudden you had algorithms that could actually understand what the content was about and match that up with sort of the right viewers. So TikTok is an AI-enabled company, and that has created all of this opportunity for these niche content producers. One of my friends, they make paper, literally like make wood pulp and then make paper as one of their hobbies. And they produced videos about them making paper, and they got millions and millions of views. It's a very niche topic. Previously there were no effective ways to get content about paper making out there. And it's not like any studio would make a show about paper making. But because TikTok enabled this distribution mechanism, because of advancements in AI, the videos went viral, and there's sort of this there's these businesses that can be formed off of that as a distribution mechanism. So I think that this is TikTok is one phenomenon of a broader trend, which is that AI is going to fundamentally enable business models that were impossible in the past and are going to require and enable a huge number of careers and jobs and economic growth in ways that are somewhat unpredictable based on how we think about the world today.
Yeah, I'd love to dig into some of the business cases in a second. But before we go there's a lot of fear mongering around AI in different countries and in the US in particular. There's a lot of talk about regulation, and we need to regulate AI to make it safe. What do you think about that? Do you think there's any validity to the argument that AI is a threat to either our national security or the well-being and employment of the population? Or do you think that that's all just fear mongering?
I think AI is a super powerful technology. And I think, like any powerful technology, I think, it's really extremely relevant for national security. And I also think it's very relevant for the health and well-being of our citizens. And so I think, if you think about the internet, for example, the internet was both. It's critical to national security. Cybersecurity is probably one of the most important sort of new frontiers of national security today. And it's important to the well-being of people. It's shown that social media can impact mental health. There's all these weird social effects that have happened that even now we don't fully understand. I think AI is similar, if not potentially even more pronounced in certain ways. So I think from the perspective of national security, I actually now believe that it is probably the closest thing to a modern Manhattan Project that we've seen since the Manhattan Project, because the sort of I think one thing we've seen is that the performance scales with investment level. And so, that lends itself to these kinds of game theoretical situations at a geopolitical level where companies need to invest dramatically or have the ability to invest dramatically into AI capability. And that's going to result in having a leg up our near peer competitors. So I think there's going to be some form of AI race. I think that's, it's happening already. It's unavoidable. And I think that it is one of the most critical technologies for the next 20 years of sort of geopolitical stability that exists. And I think we have to embrace that as a technological community and as a national security community to properly gauge and understand the risks and opportunities that the technology presents. So I think it is, frankly, it's more critical than the internet for national security because, the offensive and defensive capabilities of AI, I think are immense. Then I think if you think about sort of regulation from a well-being of citizens perspective, I think that actually hinges a little bit on the business models that form from AI being an enabling technology. So again, draw the analogy to the internet. Two very different business models on the internet. One is e-commerce. There's some amount of consumer protections that are required in e-commerce, but really it doesn't have to be majorly regulated. E-commerce is a more sort of purely good technology. And then there's something like social media or these content distribution platforms where I think problems like misinformation are really big problems, and problems like, a lot of the problems that we've sort of worked through as a society over the past, 6-7 years. And I think those are really important topics. I think that, we'll look at what the business models like enabled by AI are, whether it's, fully generated AI generated content that people are watching all the time and people are sort of like immersing themselves in. I think if that is one business model that forms, then the same problems are going to come up. How do you make sure there's no disinformation? How do you make sure there's no misinformation in AI generated content? There's going to be regulatory regimes that are going to need to take place.
And if you were president and you acknowledge that AI is just critical to national security and to our standing geopolitically, what would be your playbook to develop the U.S. into the AI superpower, both offensively and defensively?
So break it down into different pieces. I think first, it's important to create sort of a national initiative around this and create clarity in a strategy, which I think, because of obviously how political some of these issues are, can sometimes be difficult. But I'm pretty sure that AI for national security is a very bipartisan issue. And so I would create a very clear strategy and create a very clear sort of line of accountability. I think the next thing I would do is AI is fundamentally about talent at this stage of the game, just like how the Manhattan Project was about having all the most brilliant scientists and physicists, sort of work very rigorously on a single problem. I think the same is true of both where AI technology is today and where we'll go in the future. I think that not every AI scientist is going to enroll in these problems around national security, but I think some of them will. Like some of them, I think, understand the magnitude of these issues and will enroll and care about these problems. And so I think there needs to be some mechanism by which we can utilize the incredible human capital and the incredible talent that we have in the United States and enroll them in some of these in these critical national security challenges. And then I would invest. AI at the end of the day comes down to mixing three things together. You mix an algorithm with a bunch of compute and a bunch of data. And we need to build the right kinds of data centers as a country to be able to relevantly compete. We need to be able to have the right platforms to get the data that's necessary to be able to compete. And we have to utilize the algorithms and make sure we're continuing research on those algorithms as a country. And I think that if you can do those things and you align those to the use cases, both offensive and defensive, that are most relevant, I think you can create a pretty formidable program.
And you guys obviously work in different parts of the military in different ways. Do you think that the senior leaders of military and even at political levels, Congress, do you think that there's recognition of the importance of AI, or do you think people are still trying to fully comprehend and understand how important it is from a geopolitical standpoint?
Thankfully, I think everybody understands the importance and everyone understands the criticality of the problem. I think if you look at what's been happening in Ukraine and Russia, where the confluence of world-class intelligence plus, relatively cheap hardware plus sort of heroes, Ukrainian heroes, that mix of capabilities has proven to be a pretty formidable opponent to one of the greater military powers in the world, in Russia. And so I think that along with this sort of like very steep incline of capabilities that AI has been demonstrating, I think makes it clear to almost everyone that AI is really, really critical. I think what's missing is sort of almost exactly what I just talked through, is like what's clarity around the plan and what are we willing to sort of sacrifice to make sure that plan succeeds. And I think that one of the biggest gaps, which, still is the case, and I hope it stops becoming the case, is sort of this massive gulf between Silicon Valley and technologists and folks in DC. And there's this, again, they're opposite sides of the country, obvious to call out, but there's sort of like gulf in lack of understanding of both sides. I think that the DC community has a low understanding of the technology community and what matters to the technology community and what matters to the greatest technologists, and vice versa. I think the technologists often sort of misconstrue and misunderstand the sort of good intentions of the DC community. And I think that is sort of a structural harm to us being able to solve these problems.
Maybe shifting to the commercial side, which is maybe a little bit easier to tackle. When you're talking to companies today, are you guys typically selling into practitioners, to data scientists, or are you typically going in and selling this at a more executive strategic level?
Yeah, we actually do both. What we found is, so where we started as a company was at the sort of infrastructure layer. One of the analogies we always drew early on was sort of as the AWS for AI. We're building these tools and products that enabled data scientists to be able to, very quickly and easily get data sets, manage those data sets, like measure the performance of their models, do all the kinds of things that, basically tools that make their jobs way easier. And then we noticed over time that there were tons of companies who really wanted to be able to transform their businesses with artificial intelligence and machine learning, but needed sort of out-of-the-box solutions and out-of-the-box products to be able to drive that improvement. And so we did that as well. And I think a lot of that, and so I think by doing both, by both selling at an executive level and selling ready-made solutions, in addition to selling the underlying infrastructure for data science teams, that's enabled us to meet, nearly all of our customers wherever they're at. And that's a big part of our mission, is how do we enable every organization with great AI technology, and how do we enable sort of the sort of economic gains from AI being a distributed technology as quickly as possible.
When you go sell this at an executive level and sort of pitch AI as a strategic initiative, do you think most people are still considering AI as a cost-saving tool? And you sort of have to reposition it. And what we talked about earlier is this net positive with all the other optionality on top of it. Or do you think people are starting to realize that?
I think that it's a really good question. I think a lot of times I think people's natural inclinations and businesses' natural sort of posture is going to be to think about it as a cost savings tool. And I think that it's something it's deeply ingrained in how these large corporations operate, because they operate at such massive scale. So cost takeouts end up being a really attractive way to sort of increase shareholder value. Thankfully, I think if you're able to actually articulate what the value case is, or what the capability that they can have that actually enables top line growth or enables sort of business transformation that is not a cost takeout, I think they're really excited to hear those ideas. And so we focused a lot on those, because fundamentally I think that cost takeouts are only a very small part of the puzzle of AI over the next 20, 30 years. Most of the value is going to be in, fundamentally, as we kind of talked about, enabling technologies, new business models, new modalities that you have that you couldn't have taken advantage of otherwise. One way that we talk about this with our customers is that most of their businesses have not utilized, even a small fraction of the data that they capture as part of their normal business. And in particular, it's very rare to see a Fortune 500 that is actually utilizing the unstructured data within their business. So the sort of imagery or text or audio or video or, all these kinds of data formats that, might seem useless to most people, or might seem really unwieldy, but actually, hold all this rich information and context that enable you to run your business better. And so a lot of the visual that we have people think about is it's like an iceberg. They've really just only touched the surface, and there's sort of all of this value that they haven't even sort of encountered on or haven't even embarked upon.
Yeah, we sort of frame this in a way where data advantages could be the next sort of competitive advantage that drives value creation. It was like the 1900s where economies of scale, right? The Standard Oils of the world, they could just outprice their competitors with scale. And then you had sort of the network effects of the 2000s with the social media companies. And now it's really companies that have these unique data assets and they can unlock with AI. And there's tremendous value to be created on top of that. And maybe you can walk through a couple examples of how you see traditional companies using AI today. So I think it's pretty clear how TikTok uses AI or how Google uses AI. But if you take a company that's not a tech company, just a traditional kind of old world company, how are you seeing them embrace AI today?
Yeah, I'll give two really fundamental examples that we see all over the place. I'll give three actually. One clear one is in healthcare. If you look at the healthcare problem globally, there's like a huge on a global perspective. There's an incredible shortage of doctors and sort of sufficient medical care for most people in the world, and that problem, AI really is the only answer to be able to sort of effectively scale the human judgment and context that's necessary to actually offer medical care to, the global population. And on a micro level, if you think about how a lot of healthcare is done these days, it's done at an episodic level. So, you go into the doctor, they don't really do that much longitudinal analysis of your previous visits or all the previous data you have, and they sort of take a snapshot and they try to do analysis at that time. And there's this huge missing link of longitudinal analysis of medical information and health information that can only, I think AI and machine learning is the clear answer. And that has the ability to just dramatically improve outcomes, which obviously enables just a huge amount of economic efficiency. Another fundamental example that we see all over the place is logistics automation. So we work very closely with Flexport, for example, in a global freight forwarder, a huge part of the sort of global logistics economy. And we automate huge parts of the workflows of, not only things moving from place to place, but also capturing all the relevant information as, a major ship moves from port to port or a plane flies from airport to airport or whatnot. And if you think about it, most any old world business that has a massive atoms profile, basically is like selling atoms of some capacity, has a huge logistics problem. Logistics is sort of this supply chain is one of the biggest problems of any enterprise. And it's incredibly unoptimized at nearly all these organizations because the way this actually works in practice is that there's sort of decisions made at the edge without knowledge of all the other information of the sort of network or the system. And so we've driven dramatic improvements, tens of millions, hundreds of millions of dollars of savings through allowing for better optimization of logistics and basically making better decisions about how to move things from point A to point B. The last example that I'll talk about is really in enabling companies to reach their customers more efficiently and more effectively. And again, this is sort of a horizontal problem. But I think that if you think about it, almost every company has ways in which they reach their customer. And there's, the analogy from a TikTok or a Google, which is personalization, applies to every business. Every business has an opportunity to better personalize how they reach out to their customer and how they interact with their customer. And so, the best example of this is our work in e-commerce. We work with companies like Instacart or Etsy, and we basically help them build machine learning algorithms that, again, optimize these sort of customer touch points to enable better and more effective sort of commerce of goods. And that's a use case that I think has a huge amount of runway. And as our AI techniques get better, we're going to see even more gains across every business.
Just on the commercial adoption side, what are the biggest challenges for traditional companies that are building AI? It seems like data acquisition, the number one challenge, or at least quality data acquisition. You guys are solving that. What are other challenges that make it hard for a traditional company to really embrace AI in a useful way?
Yeah, I think data is a huge challenge. I think that you go to almost any company and they have just a very siloed, fragmented data portfolio. Different parts of the business have different databases. Those databases don't talk to each other. They're not in the same schema. There's this incredible amount of fragmentation that prevents any of the sort of data economies of scale that you actually need to build proper machine learning. So data, in a word, is sort of like this big hairy problem across almost every enterprise. The second really is actually problem identification. I think that most enterprises kind of have this experience where they've tried to do some science projects with artificial intelligence. They've maybe worked with some companies that have tried to do some pilot projects around AI, and it hasn't really lived up to the hype. And it's sort of this confusing thing because, we can see how impactful AI is to the big tech companies out there. Google, Facebook, Amazon, Microsoft, these companies get immense amount of value from applying artificial intelligence throughout their systems. But most enterprises have kind of yet to see those gains play out in practice. And a lot of that is because of a really problem selection. It's that the way AI works is it's not like you throw AI at anything and all of a sudden it gets 10x better. It's you can throw AI at, out of 10 things, you can throw AI at 9 of them and maybe makes those things, 5 to 10% better. And you throw AI at the 10th problem and it makes it 1,000x better. And so I think that the sort of this aspect of knowing almost where to drill when it comes to AI, is a really key one. And that's kind of, as I talked about it, that's why I think the ready-made solutions are so valuable for these enterprises, because we can show them applications that, we know are going to be one of those 1 in 10 opportunities. And we can help, prove out the business value very quickly for them.
That makes a lot of sense. And when you think about your business and building this into a very large company, what are the competitive moats for you? What makes it hard for others to compete with you?
It's a simplistic moat, but where we started as a business was all of the dirty work around AI. Kind of as we talked about, we're 6 years old as a company. Probably the first 5 years were nearly fully dedicated to just this Moore's law of data problem. How do we make it progressively more and more efficient to get higher and higher qualities of data? And that is a very hairy problem. It's a very complex problem. It's almost like Stripe. Stripe sort of, the APIs are really beautiful, but the underlying problems are very hairy and ugly. And that's really what these problems in AI are. And so our differentiator and our promise when it comes to working with the customers that we work with is we've probably done more dirty jobs for data than any other company that you're likely to engage. And that means that, there's almost nothing that you can show us in your data that'll shock us. And that'll allow you to very, very quickly arrive to, have very fast time to value and arrive at results, much more quickly than you would be able to otherwise. And we see that resonate a lot with customers. So at a base level, it's really all this infrastructure we've built up around data enables us to serve our customers so much better. That's
great. Well, thanks for joining us, Alex. And where can people find you on Twitter or elsewhere?
Yeah, you can follow me on Twitter. It's at Alexander, ALEXANDR _ Wang, WANG.
All right, perfect.
There you go.
Well, enjoy the conversation. Thanks for joining us.
Thanks so much for having me, Will. It was a lot of fun.
ARK believes that the information presented is accurate and was obtained from sources that ARK believes to be reliable. However, ARK does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARK. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARK's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.